Have a nice day, viewers. I am Cassian Perera. This is my YouTube channel, which is called Cassian Perera. I started this channel at the beginning of this year to conduct engineering lessons on engineering mathematics, thermodynamics, fluid mechanics, and solid mechanics. My students call me as Cassian sir. They like very much for this channel. If you want to subscribe, subscribe my channel by pressing subscribe button. Today I am going to discuss about some electrical engineering concepts. Those are called resistance, reactance, and impedance. Now today I am going to discuss about resistance and reactance. Now resistance, what is the resistance? Actually I am going to consider about electrical components. One is called resistor, the other one capacitor, and the next one is coil, inductor. Now you know, in our three-phase current we have AC theory, alternating current. Now in alternating current we have a sine wave voltage. Now here we got a, say, resistance R, which is connected to a voltage source, AC voltage source. Say it is V. Now it's a sine wave function. Say it is it's a function of time. Vm sine omega t. Then the current flow from this is I. I flows through the circuit and through the resistor, which is resistance is R, and I. Then we can apply V equals IR, Ohm's law, for this resistor. Voltage difference between these 2 points of the resistor is V, same V here. I is the current flow through the resistor I, and R is the resistance. R is called resistance. But V is equal to Vm sine omega t. Is equal to IR. I is a constant. Sorry, R is a constant. I is not a constant, but we can see here, we can subject I. What's I? We can write IR is equal to Vm sine omega t. Therefore, I is equal to Vm divided by R sine omega t. Then we can see I is not a constant, I is a function of t also. But if we got here this constant, Vm is a constant, R is a constant, then Vm divided by R we can choose as Im sine omega t. I equals Im sine omega t. I equals Im sine omega t. where Im is equal to Vm divided by R. But here Vm is equal to Vm sin omega t. I is equal to Im sin omega t. Now let's see what the functions are. Here we can plot the graph of V versus T. This is the graph of V versus T. Yes. Now if you got here time is there. Now how do you get this graph? Now we assume a Vm is rotating about in coordinate system like this here. Vm radius is rotating about its origin with the angular velocity omega. With an angular velocity omega, Vm is rotating in anti-clockwise direction. When angle is 0, that is t is 0, omega t is the angle, omega t is 0, then sine 0 is 0 there. When it comes to this position, omega t is 90, then it comes to this position. Then omega t is 180, it comes to this position. When it comes to this position goes there. And likewise, we can plot this by rotating vector. Rotating vector, maximum value is Vn. This is V. Now we got I versus T on the same coordinate system. Its rotating vector is Im. So its rotating vector is rotating radius is Im. Im is rotating like this. Say Im is smaller than Vm. You assume it. Different one. The same way we can plot when t is 0 here, when omega t is 90 here, when omega t is 180 here, we can have similar graph but with a less amplitude with comparing V. This is I. Now then we can think then Vm and Im ready we can coincide together and rotate. Then we get similar at the same time similar value. When t equals 0, both are at 0. When both are 90 degrees is at here, but amplitudes are different. Amplitude by amplitude it's represent Im. Im. Earlier graph, its amplitude, this wave amplitude represent Vm. Now we can say actually these radii coincide on each other, then we don't have any angle between them, then we can say both are coincide each other, but not no angle between them, no phase angle between them. When the load is resistance, then uh, we have like this V equals IR. But if you got a capacitor or inductor means coil, we get complicated. If you got either a combination of resistor and a coil, or resistor and a capacitor, or capacitor and a coil, or all three together, then it may get more complicated. Let's see the second one. This is the first one. Second one is there. Now say if you got example here, say here we have the first one example. We have to find R here. Example, if Vm is equal to, they have given like this, V is equal to 230 sine omega t, I equals 15 sine omega t. Find R. The case, first case. Then we can write here V is equal to Vm sine omega t. Then here Vm is equal to 130. I is equal to Im sine omega t. You know, same angle you have, coincide together. Then we can write Im is equal to here by this problem 50. If you apply this equals IR for this one, Vm equals Im into R. Then Vm is equal to here 130. Im is equal to 15 R. R is equal to 230 divided by 50. One, 5, 14.3 ohms. Example. Now let's see here second condition. Second condition, reactance of a capacitor. If we had the capacitor like this, capacitance is C. current flow through this one is says I. We know fundamental equation in capacitors we can use Q equals CV. V is the potential difference between these two plates. But if we differentiate it with respect to time, if we differentiated both sides with respect to time, now I am going to differentiate both sides. dq over dt is equal to d over dt cv. But dq over dt is actually, you know, current is defined in physics. Advanced level we have studied. Current flow means charge flow per unit time. Charge flow per unit time. Electric charge flow per unit time. Now, electric charge flow per unit time means rate of change of charge flow. That is the dq over dt. That is the derivative of charge with respect to time. Then we can write here current I instead of dq over dt. Now, CV means C is a constant. C is called capacitance. C is constant for the capacitor, given capacitor. Then we can take C out. C dV over dt. What is V here? V is supplied by this voltage source. It's a variable sine curve Vm sine omega t. Now we have to differentiate V with respect to time. V is called Vm sine omega t. Vm is a constant, we can take out Vm. Then we have only to differentiate sine omega t. Then we can write here I is equal to C Vm. If we differentiate sine with respect to omega t, then we get cos omega t. Then we have to differentiate omega t with respect to time. Then we get omega by applying chain rule. We can't directly differentiate sin omega t with respect to time. Therefore, we are going to differentiate sin omega t with respect to omega t first into omega t differentiate time with respect to time. Sin omega t with respect to omega t is cos omega t. Then omega t with respect to time is omega. Then we can write here Vm omega c cos omega. Then we can write I is equal to, say, this is Im constant, Vm is constant, omega is constant, c is constant. Omega is the angular velocity, cos omega. Now, if we wrote with the sine function, then we can write sine 90 plus 90 means pi divided by 2 plus omega. Earlier we had similar angle for voltage and currents, but here voltage is omega t angle, and but angle for the current is omega pi divided by 2 plus omega. Therefore, angle in the current is pi divided by 2 radians in advance with respect to the angle in voltage. Then we can represent here, if you got sin omega t curve I plotted earlier, sin omega t curve, but here sin omega t curve is like this. This omega t 0. This is omega t pi divided by 2. Because given this time is here, omega t is 0, that is 0. Say omega t is pi divided by 2 here, that is t is equal to pi divided by 2 divided by omega. Here omega t is pi, we have pi divided by omega. Likewise, we have this. That's for the voltage. When t is 0 here, for the current I, that is equal to Im is equal into sin pi divided by 2. That is sin pi divided by 2 is 1. Im into 1 is Im. Here is 1. Im. When omega t is pi divided by 2, pi divided by 2 is here. Then what is happening here? Pi divided by 2 plus pi divided by 2 is pi, sin pi 0. Sin pi 0 means Im into 0 is 0 here. Then it's curved like this. You get maximum here, then 0 here, maximum here, 0 here. That is actually this V current, V voltage value is always pi divided by 2 angle behind from the current. Now if we draw a rotating vector diagram, say if you got this is the Vm, when Vm is at 0, omega t is 0, omega t is 0, Vm is that Vm into 0 is 0, V is 0. Then omega t is 0, what is happening here? Sin pi 2 divided by 2 plus 0 means sin pi divided by 2, that is sin pi divided by 2 is sin 90, that is 1. Im into 1 is Im. Im is there. Im is at 90 degrees. Im is 90 degrees advanced compared to the Vm. That is Im, this is Vm. Both are rotating in anti-clockwise direction, this way. Therefore, we say the angle between these two vectors, rotating vectors, is called phase angle. Here phase angle is 90 degrees or pi divided by 2 radians. That here we say I current always leads the voltage V. I current always leads the voltage V by 90 degrees. Sometimes we call this 90 degrees angle is called phase angle, that is leading phase angle. Leading phase angle. Always we say current is leading or not voltage. Here in a capacitor, current is always leading voltage. Now we have Vm is V is equal to Vm sin omega t, I is equal to Im sin omega t. What is Im here? Im is equal to Vm omega c. We wrote Vm is equal to, if we subject Vm, Im into R, earlier we wrote, but here Vm is equal to Im into 1 over omega c. This quantity we write as Xc. This is called reactance. Reactance means the resistance like thing of a capacitor. Resistance like thing. Yes, so Xc is equal to 1 over omega c. If we substitute the value with omega and c, then we can find the reactance. The units of reactance is actually ohm. Units of reactance ohms. Now let's see an example. Example. An example says if simple f is equal to 50 hertz and c is equal to 200 microfarads, find reactance of the capacitor. But here what is the reactance? Xc is equal to 1 over omega c. Omega is the angular velocity of the rotating vector. Both v and I rotating vectors are rotating in the same angular speed omega. Omega we can write as 2 pi f. Then we can write here is equal to 1 over 2 pi f. See. Then we can write here 1 over 2 pi f means 50. C means if they have given in hertz, 50 hertz. That is the frequency of the current here, and 50 into C is 200 microfarads. 200 microfarads means to become farads 10 to the minus 6. 1 over here how much? 2 into 50 is 100. 100 into 200, 100 into 1 into 2, 2 pi into 100. 100 means 10 to the power 2, 10 to the power 2, 10 to the power 2. Here 100 pi, that is 10 to the power 2, 100 means 10 to the power 2. Here 200 means 10 to the power 2, 10 to the power 4. 10 to the power 4, 10 to the power minus 6 means 10 to the power minus 2. 100 divided by 2 pi. That is, we can write 50 divided by pi. We can find the answer finally in ohms. Beautiful. Just simplify using calculator. Now, let's see the next one, reactance of a coil. coil inductance is L. What is the inductance? Let's see what the inductance is. Inductance is defined as, now say if you got a coil, you have magnet, bar magnet or something. Around the bar magnet we have a coil like this. Here we have magnetic field phi. Now we have say n number of turns. This is the field phi. Flux is phi. Then we can define flux linkage. Flux linkage means flux linked with this turns of the coil. That is defined as n phi, n into phi. Now, inductance is defined as, that is the flux linkage per unit current. Flux linkage per unit current. Then we can display the result as like this. L is equal to n phi divided by I. Then we can write finally Li is equal to n phi. Now say if you got a coil like this, if you have supplied some current flow through this coil, then what is the electromotive force between these two ends of the coil? Its value, magnitude, we can write like this. Here is equal to, that is rate of change of flux linkage. Means now we can say flux linkage, rate of change of flux linkage, that is here we can write like this. The magnitude of this electromotive force of voltage difference between what difference between the two ends of the coil is equal to rate of change of flux linkage. Then we can write modulus of E is equal to dO dt n phi. Rate of change of means the flux linkage per unit time. Change of flux linkage per unit time, that is d n phi over dt. But n phi you can write as Li as mentioned earlier. Then we can write here is equal to d over dt Li. But L is a constant, we can take it up. Say this is actually, this E is equal to V. V is equal to, we can write L out d over dt I. V we can substitute here. We have voltage source here, Vm sin omega t. We can write di over dt is equal to, we can subject dI over dt, Vmol sin omega t. Now how to find I now? We can integrate both sides with respect to time. If we integrate it, both sides with respect to time. What is the meaning of this one? Differentiate and integrate. Differentiate, integrate means no change happened here, therefore I. Here we have I, this side we have I. Vm divided by L is constant. Vm is constant, L is constant, therefore Vm divided by L is constant, we can take it out. Sin omega. If we integrate sin omega t, what is happening here? If we integrate the sine, it becomes minus cos. Minus cos omega t divided by omega. Omega is a constant, we have divided by. Now here it becomes omega, we can take it out. Minus sign we can take it out. Minus Vm divided by omega L cos omega. We can write here Vm divided by omega L cos omega t. We can write in sine. Sine cos theta is equal to sine 90 minus theta. Sine 90 means pi divided by 2 minus theta means omega t. That is I is equal to minus Vm divided by omega L sine pi divided by 2 minus omega t. Actually this is trigonometry. No electrical concept here using here. Cos theta is equal to sin 90 minus theta. It's a fundamental trigonometry. Minus sign we can take with the into the sign here, then we can say Vm divided by omega L into minus sin 90 minus omega t, or pi divided by 2 minus omega t. In trigonometry we have minus sin theta is equal to sin minus theta. Trigonometry we can prove minus sin theta means minus times sin theta means sin minus theta. That is the minus 1 times sin theta is equal to sine of the minus angle. Yeah, then we can remove this minus sign, put into the angle by multiplying the angle by minus 1. Vm divided by omega L sine. If you multiply by this one, minus pi divided by 2, minus into minus plus omega t. We can write same thing here like this, sine minus omega pi divided by 2 plus omega t means omega t minus pi divided by, same thing. That is I. Here we have used trigonometry. Here cos omega t is equal to sin 90 minus omega t. That is this principle. Cos theta is equal to sin 90 minus theta, or sin radian pi divided by 2 minus theta. These are fundamentals in trigonometry we have used here. But here minus sin theta is equal to sin minus theta we have used here. These are coming under the A level, advanced level trigonometry syllabus. Fundamentals. And here now we know I is equal to Vm divided by omega L sin omega t minus pi divided by 2. We can write I is equal to Vm divided by omega L sin omega t minus pi divided by 2. V is equal to Vm sin omega t. I is equal to Vm divided by omega L times sin omega t minus pi divided by 2. Now here again we can see sine angles are not same. Like in capacitor, case of capacitor, here in inductance also we don't have any same similar angle like in resistance, but here current angle is pi by 2 less than the voltage angle. Voltage angle is omega t, current angle is omega t minus pi divided by 2. Now if you plotted curve, this is the Vm, that is V curve. When omega t is 0, omega t 0, 0, 0 means here, this is t, omega t is 0 means here, omega t is pi divided by 2 is here, omega t is pi is here, omega t is 0 means here, when omega t 0 is here, V means here, 0, but omega t is 0 means, if you put 0, if you have put 0, this 0, sin minus pi divided by 2. Sin minus pi divided by 2 means, sin minus pi divided by 2. That is, you can write minus sin pi divided by 2. Sin minus pi divided by 2 means minus sin pi divided by 2. Sin pi divided by 2 is 1. That is, sin minus pi divided by 2 means minus 1. Here minus 1. Minus 1 into Vm omega L here. Minus Vm divided by omega L. When omega t is pi divided by 2, this is omega t is pi divided by 2, sin pi divided by 2 is 1 Vm, because Vm omega t is pi divided by 2 means this becomes 0. Pi divided by 2 minus pi divided by 2 means 0. This becomes 0. Sin 0 means 0. This whole thing becomes 0. Then act here. Now we can have the rotating vectors. Say this is the Vn. When t is 0, it's at this position. When t is 0, this sin minus pi divided by 2. The angle is minus pi divided by 2. Here, I is there. It is pi divided by 2 goes back. Actually, this Im is behind the Vm by pi divided by 2 radians. Actually, it's like this. Then they are rotating like this. Omega, omega, Then we say there is a phase angle between them is 90 degrees of gradient pi divided by 2. But Im is lagging voltage. I is lagging, current is lagging voltage by radians pi divided by 2. Lagging is behind. I lags the voltage by pi divided by 2. This is the phase angle lagging. Now then we can say both are not in one phase, voltage and current, when the load is a inductor or coil or capacitor. Now next lesson I am going to explain when we have inductor and current, uh, resistor, or resistor and a capacitor, or all three together, what happened to the system? How do you find the total reactance? Now actually total reactance or impedance. Next time we are going to discuss about impedance. Now here this is the picture we have. Now this one here we can write here I Im, this is Im, sine omega t minus pi divided by 2, where Im is equal to Vm divided by omega m. If you wrote this equation Vm is equal to Im into R, like, then we can write Vm is equal to Im into omega m by cross multiply. This is called reactance of the inductor. Then its XL is equal to omega m, or we can write sometimes 2 pi f a. Yes. Now let's see some example. If f is equal to 50 hertz, L is equal to 300 millihenry. L is measured in Henry. Then they ask me what is the reactance. This is called actually reactance of the coil. Two pi f means 50. L is 300 into 11 minus 3. Millihenry must be in Henry, otherwise not correct. Standard units, the SI units, we are converted into SI units. Then XL is equal to 100 by 300 into the power minus 3. Here 10 to the power 2, 10 to the power 3, 10 to the power 4, 10 to the power 4 into the minus 3 means 10, 10 into 3 pi, that is 30 pi ohms. And convert, you have to simplify further using calculator, then it's in ohms. Now next video I am going to consider about impedance when we have two of them together in series connection or parallel connection, or three all together in series connection. Now if you want any questions, you can ask me for an exam for your knowledge. uh, you can contact me. My number is contact number is this one. My name is Cassian Perera. My Gmail address is this. Cassian@gmail.com. You can email question if you want to know about the answer, then contact me. Thank you very much for your audience. Now here, thank you very much, and I wish you a better future. Thank you.